Engineers, India. Professor Kalamdhat Sir was also awarded with the ISTE GSITS National Award for the Best Researcher in Engineering Colleges for the year 2012 by the Indian Society for Technical Education, India. He is a member of the editorial board of the International Journal of Environmental Science and the Integrated Publishing Association. Professor Kalamdhat Sir completed his BE in Civil Engineering from Government Engineering College, Jabalpur, and did his MTech in Civil Engineering from Visvesvaraya National Institute of Technology, Nagpur. He also holds a PhD in Civil Engineering from the Indian Institute of Technology, Roorkee. His
I don't know any
specialization
explanation, sir.
his specialization is in environmental engineering. Sir has served as a project assistant at the National Environmental Engineering Research Institute, Nagpur, and then as a research intern at the Regional Research Laboratory, Bhopal. He is currently a professor at the Indian Institute of Technology in Guwahati. I heartily welcome Professor Kalamdhat Sir to this technical session of the Faculty Development Program. Today, Sir will be discussing on the topic potential of biogas production from petroleum refinery sludge. Without further delay, I request you, Sir, to take over the session and enlighten us all. Thank you, and over to you, Sir.
Thank you, Ms. Tanishq, to talk about myself. So normally in IIT Guwahati, if you visit, I think people, if you ask everyone where is garbage guy, where we can find, they will easily they can talk about myself. Like I'm properly known as a garbage guy of IIT Guwahati. We're working in solid waste management from last 25 years. So I'll just first share the slide. Is able to see the slide?
Yes, sir, it is coming.
Just is a full view?
Yes, sir, yes.
Just tell me the second.
Yes.
Yes, sir, it is running, sir. Smooth, sir.
Okay, yeah. So once again, thank you, the organizer, for asking me to give one presentation here in this FDP. So actually, I was not ready exactly what to talk about petroleum refineries because I belong to civil engineering, but we are trying that different industrial, because these industries are known to be one of the most polluting industries, and even petroleum refinery also known to be one of the top 5 polluting industries. And many people, like especially in civil engineering, those who are based from environmental engineering, they're working on wastewater treatment. Okay, but very few people are looking onto the researcher looking onto the what kind of sludge these industries are generating. So here I'm trying that what in the entire world is looking after this biogas production from the petroleum refinery sludge. Even what exactly we were doing at IIT Guwahati, and also I'll tell about how beneficial will be the this kind of idea. Okay, so hope I think in the previous lecture also you people have came to know about few recycling, few petroleum refinery processes uh, and other ideas. I don't know exactly, but I'll just start with the I think how these sludges are getting generated and how important to discuss about this issue. So this is normally the is everyone knows about refining processes, and this is the normal hydrocarbons is getting generated, intermediate product, and these are the final refined products is generating from the refinery processes. Like mostly we know that this fuel gas, refinery fuel gas, diesel, and many other products are coming from the refining process. And there are number of refinery industries are there in India. Like especially if you see the Arabian Sea, and even Assam is known for these kind of refineries in India. So it's around uh, 600 million tons. The oil reserves is available as per the 2016 data, and 59 mega tons petroleum products were exposed, making one of India one of the largest refined oil the producing country. She is after USA and China, the largest consumer of crude oil in the world. And also this news become very popular. Like India's oil demand will rise up by 50% by 2030 against the global expansion of 7% only. So I don't know whether we are all ready to have to manage these kind of demand. So along with this processes will generate a lot of wastewater that mostly we call as in waste oil. Okay, from whether it's from intermediate product, whether it's from final products, and these became this waste oil is mostly a organic inorganic pollutant and is very polluting hydrocarbons, even phenol, and degradation is very difficult, especially the phenol, hydrocarbons, BTEX, even heavy metals. Also, there is a good amount of heavy metals is generating along with this waste oil. And this one of the study is available in the US. They were mostly talking about toxic air pollutants is coming from the refineries. You see, the problem is saying that refinery release toxic air pollutants, which can cause cancer and many other issues. Like 2,200 tons of hazardous air pollutant is getting generated. That is one of the report given in the EPA, US EPA. And these toxic, because these are carcinogenic, is a hazardous metal. I have a lot of health issues is coming out from whatever the air pollution. I don't think so in India we have the studies available how much air pollution is coming from these refineries. Even not only the release of air, but the waste oil, which I was in the previous slide I was talking about, they have very difficult to treat, and you is not easily we can dispose of without any treatment. So, but I think as per my information, all the refineries in India have treatment processes are available. The effluent treatment processes or whatever the wastewater is getting generated is mostly a waste oil is getting treated by different methods. But mostly you see here, I think this is the one, the major processes I showed based on the different literature were getting treated. And because this wastewater treatment, the lot of oil sludges is getting generated, that is mostly a physical in nature, oil sludge, chemical sludge, especially from the flash mixer process. And from the last point, like settling points, will generate a lot of biosludge, that is biological in nature. So all three kind of different sludges are getting generated. Just I'll show you some of the photograph you will be able to see. Here the oil sludge is generating from the physical treatment process. This is chemical sludge from the chemical treatment process, and finally biosludge from the biological processes or settling processes finally. And these all kind of these sludge are highly carcinogenic, highly hazardous in nature. And I don't know in refineries some methods are available to treat that. And mostly in refineries you will find one pond where this kind of sludge is getting stored. But I never found any treatment processes how they are treating that. Okay. But this is very problematic one and is creating a lot of issue, these sludges, and the generation itself is very high. I'll just give one some of the data. So as I told, is already cytotoxic, carcinogenic in nature, is not good for the human health as well as for the environment. So some facts you see here, 1 kg of crude oil will generate 10 to 20 gram of oil sludge, and more than 60 million tons of oil sludge estimated to be produced every year. 60 million tons, and more than 1 billion tons of oil sludge has been accumulated worldwide. It's not only in India, but 1 billion tons of oil sludge is getting generated. You can see this is one of the news, like the oil sludge contains compound have carcinogenic effect, which is why the waste management system that process oil sludge are very important to protect the public health and also environmental health. This is one research paper. We'll see the treatment and disposal of refinery sludge Indian scenario. And this research paper shows that the refinery in India generate around 28,220 tons of sludge per annum. It's a very good, huge quantity is getting generated. And even the paper also says that various type of pollutants like phenol, heavy metal are present. Even they see is also name of heavy metals is given, like nickel, chromium, zinc, cadmium, copper, lead. These are all hazardous metals. So also one of the another research paper where they have compared the sludge generation and along with that treatment process in China. So the study says like the medium size refinery where refinery capacity is 1200 to 1200 12,000 to 15,000 meter cube per day generates around 30,000 tons of oil sludge annually. This is from China and few more different countries. So what kind of treatment disposal of refinery sludge normally? In India, I don't think so. We have treatment facilities are available, but in European country, they go for incineration. So incineration will have like rotary kiln and fluorized bed because it's a light matter, so it's good for incineration at fluorized bed facility. Even rotary kiln also is one of the very important technology for the combustion of these kind of sludges. Even some countries they started oxidation plants for the sludge treatment because it's a lot of organics are there, so the easily that oxidation can be possible of those, especially for biosludge where the organic content are good. And some countries like India also is doing the sludge stabilization. Very simple method, or you just land farming treatment. This also I think is very popular because it's a economical process somewhat. But when you take that incineration facility, it's become very expensive, and again after incineration, huge amount of ashes are getting generated. That is solid residues. Even while combustion at 900 or 1000 degree temperature, generate lot of flue gases. That also again we have to treat it before putting to atmosphere. So it's very expensive method. And oxidation, we require a lot of chemical requirement in the oxidation process. And oxidation, but again, we get a lot of wastewater will get generate in the oxidation process. That also again we required another treatment facility. And sludge stabilization and land farming, obviously it required a lot of land. For earlier days, refineries used to be outside of the city, but nowadays, uh, I think you visit any refinery, it's very close to city. Finding this kind of space every time or this kind of land is very difficult. Like take example of Guwahati refinery. Whatever the space they are available inside their campus, I don't think so. They can work in this kind of management. They can work for more than 2 years or 3 years. So this is one of the report says that. So see, the Recon announces RMB 9 million contract for disposal of oil sludge. है ना, ये China, you see how much money China spending millions of currency of oil sludge disposal at reclaimed land. So we already need alternate source of energy. So not only not only we required to manage the waste. Just hold on. Hello. अरे 4:30 एक presentation चल रहा है. ठीक. So we need also we need in India, developing countries, alternate source of energy we required. If you see this crude oil reserve vanishing at the rate of more than 4 billion tons per every year, and maybe it will get over by the next 53 years, one of the reports says. So oil will end by 2052, gas will end by 2060, coal will end by 2090. Then what we'll do in next uh, 50 years? So great demand of utilizing alternatives, the sustainable goal or sustainable energy generation. So this report says that how long will world's oil reserve will last? 53 years. So as per the Beyond Petroleum in 2019 is the British Petroleum report. So what will do after 50 years? So if you see the characterization of this sludge, refinery sludge, we call it in PRS, can be a potential resource for biogas generation. Then we found that the calorific value of different type of PRS, whether is a physical process, from chemical process, or any biosludge process, is very good calorific value we're getting it. Could be 17,000 to 19,000 kilojoule per kg. And popular treatment choices, combustion technology, incineration, pyrolysis, is a advantageous. There are some studies done in China. China is trying. You can see there are 2 research paper also I found. They propose that because of huge calorific value, the combustion will be more beneficial or advantageous. But the characteristic of PRS vary greatly in moisture content. That moisture content sometimes will be very low, like 6%, and many times is found to be a 80%, up to 80% moisture will get it. And if you go for combustion or incineration of such kind of sludge, I don't think so is become more economical, because we require a lot of energy to remove first the moisture content, and then only the combustion will go ahead. So, but if you see that PRS could be a potential substrate, because it's already good amount of organic matters are there, and also the moisture content is there. So why not we can propose this kind of material for biogas production. Okay. So first, I think I'll talk on anaerobic digestion. What is anaerobic digestion? And then I'll show some of the literature and our work, how beneficial could be anaerobic digestion of these kind of sludges. So normally anaerobic digestion says that is a controlled process involved microbial decomposition of organic matter in absence of oxygen. Or in other technical way, we can say anaerobic digestion is the absence of any terminal electron acceptor, mostly is a oxygen. Okay. And with this anaerobic digestion process is generating two major gases like methane and carbon dioxide. These are the primary component of gases. There is a major gases and some trace gases like trace amount of hydrogen sulfide, nitrogen, hydrogen will get generated. But the major concentration will be methane and carbon dioxide. And whatever the material left after the anaerodization process called digestate, okay, whatever the outlet is coming, and which is normally very rich in the nutrient. But in India, when we say the anaerobic digestion digested, the outlet of the anaerobic digester will, they can consider compost, but it's not proper compost. It contains a lot of nutrients, and many locations where these anaerobic digestion processes are getting installed, where they have this kind of facility where digested is separated into solid and liquid, and this solid they consider as a compost, or they are proposing as a compost preparation of that, and the liquid is again getting recycled into the anaerobic digestion process. So just to explain this way, like organic matter, whatever the organic matter, whether is a refinery sludge or any kind of organic matter, will feed it into digester, anaerobic digester, outlet will get digested, and in the digester will generate biogas. This biogas can be directly, we can heat it for cooking purpose. We can consider that biomethanation, and directly that biomethane can added into the gas grid. India do not have such kind of facilities, but this is also a very popular method. Directly we can put it, or otherwise this CNG, that bio CNG, we can utilize for the fuel. Nowadays, everyone is talking about CNG based vehicles. Could be possible in Northeast also. So just I think some days before, our CM also has proposed that we'll have some vehicles will travel by CNG. And also we can generate electricity, directly power also we can generate out of that. So just to share with you people, like the first time this professor like John Baptista was the first person who found in 17th century that decaying organic matter could result in flammable gases, first time. But don't get surprised that first digestion plant was built in Bombay, now Mumbai, in Indian year 1859. That is the first digestion plant. You see the composition of biogas, as I shared in the previous slide, like methane could be a 40 to 70%, carbon dioxide 30 to 60%, and some trace gases be 2%, 5%, hydrogen sulfides. And if you see the relationship between methane and carbon dioxide, here methane is a combustible gas, but carbon dioxide is not combustible at all. So this is the reactor. So this graph shows biogas with the time. So the methane will be always high compared to CO2. But in time, suppose in the digester, if the carbon dioxide production is more and methane percentage will get reduced, then there won't be any burning. Means I think that gas is not able to utilize for any method, whether it's for CNG process, whether it's for gas grid system, or whether it's for heating purpose, whether it's for power production. It's not possible at all. So just remember that if the gas, whatever the biogas is getting generated, if the carbon dioxide percentage is more than 44%, so it won't be a combustible gas. Even we can't go for cooking also from that gas. So what are the different stages in the anaerobic digestion process? It has 4 different stages. The first is hydrolysis phase, acidogenesis phase, acetogenesis phase, and finally methogenesis phase. And here all microorganisms are involved in each stages. Okay. So this is a complex organic matter is hydrolyzed first by hydrolytic bacteria and followed by acidogenesis by fermentative bacteria or acetogenic bacteria, and followed by final that acetic acid production by acetogenic bacteria, and that acetic acid will break down by the methogenic bacteria, and finally in this stage methogenesis process will generate methane and carbon dioxide. So what are the role of microbes in anaerodization process is very important, and mostly the role played by methogenesis process. Here you can see is methogenesis process, and also but initially we require the acetogenic bacteria which will degrade the initially and convert into acetic acid. Here again, one by one stage, we can see that hydrolysis, where insoluble complex organic hydrocarbons are converted into soluble monomers. That is the hydrolysis process. Just for example, hydrolysis, the cooking at home, that is a hydrolysis process. Okay, where cellulose is getting converted in sugar form. So here, the similar way, hydrolysis is required. Okay, is a very slow process, and very important that is a rate limiting stage in our the entire process, or all four stages. Hydrolysis is a rate limiting stage, means we have to work more onto the for hydrolysis of the particular organic matter, and this is the micro biochemical reaction involves. The second stage is acidogenesis, where in this process hydrolyzed products are converted into simple molecules with low molecular weight. Okay, that could be mostly a propionic acid and butyric acid will get generated. Intermediates we call. Okay, it affected by the diverse group of bacteria, and which is capable to bringing down the pH inside the digester to 4. Okay, only in the acidic pH only it will work. Okay. Third stage is acetogenesis, that is a product of acidogenic stage are convert into acetate, H2 and CO2. These intermediates finally will convert into acidic acid and hydrogen finally. So there are two type of different bacteria. Acidogenic bacteria is working is a H2 forming bacteria, and homoacetogens catalyze the acidic acid to the CO2 and H2. And finally, from acidic acid, the last stage, that methanogenesis is the last stage, in which the methogens creates methane from the final product of acidogenesis. That is two pathways. First is from this acidic acid, that CH3COOH will convert in methane and carbon dioxide, and also minor pathway like carbon dioxide will react with water. Somewhat is very difficult to solubilize the carbon dioxide, but also some amount also is generating by this method. So what are the factors affecting anaerodization process? Like first factor is temperature. This parameter plays a major role in physical and chemical property of substrate and affect the thermodynamics and kinetic reactions. Anaerobic process can occur in wide range of temperature like psychrophilic, mesophilic or thermophilic. It's very obvious like at different temperature the degradation could be possible. Like, but if you see this graph where relation showing the temperature and growth of methogens, we required good amount of methogens to for getting more amount of methane gas. So here is very obvious, like at mesophilic temperature, where temperature is less than 45-degree temperature. Mostly our reactors or digesters are working at mesophilic temperature, where methogenesis bacteria generation rate is very low compared to thermophilic reactor. But problem with thermophilic reactor, we have to provide good amount of energy to get that kind of temperature, like 60-degree or 70-degree temperature in the digester. So his rate of reaction doubles for every 10-degree rise in the temperature, up to an optimum after which reaction rate declines rapidly. Okay. So many places, that's why you see that this digester is putting into the underground mostly, because is highly affected by the local temperature, ambient temperature, especially in India where temperature is close to zero, in North India or some other part of India where 4 degree, 5 degree ambient temperature. In that case, methane generation will obviously will affect. But yet if you do it at mesophilic temperature, uh, we'll get more stability, better richness in anaerobic digester. Only the yield will be lesser compared to thermophilic temperature. So too high temperature also is not good. Okay, but is okay. Mesophilic temperature is well accepted for the biogas production. Another parameter is pH. These parameter will affect the overall efficiency of digestion process. Because please remember the different stages, like in the acidogenesis process, the pH will reduce, then only the acetic acid will get generated. But in methogenesis process is only possible when the temperature in the reactor will be neutral. Only in the neutral pH only these methogens will able to generate methane gas. Okay, so that's why pH is very important parameter. Uh, Normally methogens is effective at pH, neutral pH 6.5 to 7.5. So to maintain the constant pH in the reactor, it is essential to control the relationship between the volatile fatty acids and bicarbonate concentration. So how much is the bicarbonate generation in the reactor, so that this PFA will reduce the pH and this bicarbonate will increase the pH. So this bicarbonate become a buffer in the digester. So in acidogenic bacteria then flourish, lowering the pH less than 5 will inhibit the growth of methogens. Once the reactor pH is less than 5, then it will inhibit the growth of methogenic bacteria. And if pH is more than 8, that proves to be a toxic to most anaerobes, which inhibit their biological function. The pH become a very important factor for the gas production. So if you see this graph, where we can see that the maximum amount of methogenic activity or acidogenic bacteria, this activity is very good at neutral pH. Okay, so here methogens, this graph is methogenic bacteria to pH. So optimum pH ranges to 6.8 to 7.2, up to go 7.5. Now here, because pH, along with that, we need to also discuss on buffering capacity. So obviously in the biological matter, good amount of nitrogen is available. And because of this ammonia, because of degradation of this protein, ammonia will generate, and that will react to carbon dioxide and will generate ammonium carbonate. Like this is the first one. This ammonia will react with carbon dioxide. It will generate ammonium carbonate. This is one form of alkalinity in the reactor, or degradation of salt, that will also generate alkalinity. Sulfate reduction also will generate alkalinity. And because of that, when the pH in anaerobic system drops due to VFA accumulation, this alkalinity present within the system neutralize the acid and prevent further pH drop. That is what the very important to see that how much is the nitrogen content is there in the organic matter. Another parameter is that carbon to nitrogen ratio. This is very important. If the nitrogen concentration is low, then obviously will be required more longer duration for the degradation process. Okay, because the microbial consortia will be lower they won't be able to flourish if the nitrogen content is low. If nitrogen content is high, then it will generate more amount of ammonia. So one way ammonia is good for the buffering capacity to maintain the pH, but more amount of ammonia also will inhibit the entire process. So I think similar things we can see that when the food waste, if you are feeding into digester, is always failing because if you don't treat it properly or don't combine with the proper concentration of carbon in the reactor, it's very difficult to run with the food waste also. But carbon serves as a source of energy and nitrogen controls the microbial population. So because of that, the ratio of carbon to nitrogen plays important role in the process. So if CNG ratio range 20 to 30 has been found to be mostly suitable for various type of organic matter. Another parameter is OLR, organic loading rate. This also is very important parameter. If the high OLR will alter the digester environmental inhibiting the microbial activity during the initial stage, and that low OLR leads to underutilization of microorganism, leading to very slow rate of anaerobiation process. So that's why optimize OLR, organic loading rate, has to be finalized. So these actually we have when we start the feeding the reactor. By that way also we can finalize how best OLR we can propose for any substrate or any organic matter. Another parameter is HRT. HRT is the average time that the organic substrate or any organic matter remains in the digester. So lower the HRT, more beneficial. It is desired to be long enough to provide sufficient methogenic activity. In HRT is shorter for AD at high temperature, but also is depend upon the sludge to sludge or waste to waste. And based on that is HRT only size we are finalizing. Which size, how much quantity, and what kind of size will be required. That is finalized or designed by this HRT only. Another parameter is volatile fatty acids. This is what we are looking to generate more amount of volatile fatty acids, like especially acidic acid, so that these acidic acid will only generate the methane and carbon dioxide. But accumulation of VFA leads to lowering of pH and suppressing methogens. So in acidogenesis, two major VFA, that is butyric acid, will favor the methane formation. Now acid contributes almost 70% of methane formation. Remaining volatile fatty acids like propionic, valeric or butyric acids will contribute remaining 30% of methane generation. That's why VFA concentration is a good indicator for monitoring performance of anaerobic digestion process. So there is another thought like biogas enhancement from any organic substrate through pre-treatment process. So already we saw that hydrolysis is a rate limiting stage, and why not in hydrolysis itself we can propose the pre-treatment process. So this pre-treatment is any process of initiating or improving the efficiency of microbial attack. So what it will do in the pre-treatment process, the compact structure of substrate will disturb and is exposed to the microbial attack. So this pre-treatment we can do by physical process, by chemical or biological process, or we can go for different combinations. Okay. So through pre-treatment of any substrate, not only the biogas yield can be increased, but also higher calorific value of gas can be obtained, leading to less effort in the purification of biomethane production or bio-CNG production. The biogas enhancement, what is the need of pre-treatment? Like readily biodegradable and soluble organic matter is unavailable, then we can propose the pre-treatment process. When the rate of hydrolysis through conventional anaerobic digestion is lower, in that case we can follow pre-treatment. If the lower biogas yield, then we can go for pre-treatment. Just to explain, uh, by this you'll be able to understand here. So any sludge is a now with the biosludge also you can take example, is a extracellular polymer substrate. Once you go for pre-treatment process, it will have, this is the way after after pre-treatment process. So now earlier here is the one where bacteria is very difficult to reach with the organic matter. But if you go for pre-treatment, you can easily, the bacteria can directly utilize this organic matter, green color. So here hydrolysis step become rate limiting. That's the same pre-treatment process. There's the other way where biogas enhancement we can do by co-digestion process, anaerobic co-digestion. So normally we do the anaerobic digestion for only one material or one particular substrate. But simultaneously, if you mix 2 or 3 different substrate, that we by that way is more beneficial and can possible to enhance the biogas production. So the use of co-substrate improves the biogas production in methane wield due to many different thoughts. Major is that it will maintain the carbon to nitrogen ratio properly. So substrate having high CN ratio, monodigestion has poor process stability. And so addition of nitrogen rich co-substrate at optimum ratio enhance biogas degradation. So just for one example, like co-digestion of different feedstock with animal manure can increase biogas production from 25% to 400% compared to monodigestion of the same substrate. So co-digestion of pig manure with glycerol. So if you mix these two, like pig manure CN ratio is 24, glycerol is 1. So it can increase the 400 times the biogas production is possible. So here also you can see that here is the there are few substrate, few materials for low CN ratio, and here there are few materials for high CN ratio. If we mix both in the optimum ratio, we can generate very good quality and also the a good amount of the biogas production possible. So here in this table you'll see that relatively lower CN ratio of cow dung is all kind of material. This is relatively high CN ratio like rice straw, wheat straw. These are basically organic residues, agriculture residues. If you mix with this one, like take food waste with rice straw, food waste with wheat straw, food waste with any other high carbon substrate, so that the biogas production will be good. So these are the few literature on anaerobic digestion of petroleum refinery wastewater. So you can see in 2014 in Malaysia, role of biogas recirculation in enhancing petroleum wastewater treatment efficiency of CSTR technology. This is another literature on Malaysia, like effect of food to microbe ratio, variation in anaerobic co-digestion of petroleum wastewater with manure. This is in China, where they also tried the wastewater treatment, produce biogas. This is also the combined effect of ultrasonic and microwave pre-treatment of biomethane generation from co-digestion of petrochemical wastewater. And many such, but on sludge work done is very limited. This all literature which I showed it, that is on wastewater but very few studies are available on sludge treatment or biogas production from the refinery sludge. These are the few, like in 2015, a study done in US reported higher biogas production from waste activity sludge than oil sludge, oily sludge. And the biogas from this waste activity sludge further doubled after oxidation pretreatment. Okay. This is one literature. Is another literature in scientific report, like China. In China, there's biogas production from waste activity sludge. They also tried with the pre-treatment at 170 degrees centigrade heat. Is another literature in 2018 in Abu Dhabi, that maximum biogas generation when 60% petroleum hydrocarbon waste was co-digested with 40% wastewater treatment sludge at mesophilic condition. So same thing also I shared, like co-digestion is more beneficial. So now these are some successful work done by Waste Management Research Group of my own group, WMRG, on anaerobic digestion of petroleum refinery sludge generated from ETP or wastewater treatment facility of Guwahati refinery. So we collected this sludge is from Guwahati refinery. This is my PhD students. So it's very difficult to collect the sludge. Getting permission also is very difficult. Was very difficult. Now also they are not ready to give us the sludge. So when we initially characterizes that, so you see the initial characterization of refinery sludge. The volatile solid is very good, 75%. Moisture is also very high. So because of that, we can think of we can go for biogas production. Then we started this 1 liter BMP setup we called to know how much methane could be possible. That is a 1 liter biochemical methane facility we called as in BMP. And normally is required, the entire process was required 70 days process. Some data I'll show you. Here we maintain the different I by S ratio, the inoculum to sludge ratio. So we targeted like inoculum, that was cow dung. One inoculum was cow dung because the nitrogen content was very low in the initial material, and the microbial consortia also was not available in the sludge, refinery sludge. So we thought of, I think we'll add some amount of inoculum, whether inoculum could be a cow dung, fresh cow dung, or we can take digested, whatever the running biogas treatment facility on anaerobic digester, whatever digested is there, that digested also we can use as an inoculum. So different inoculum, and successfully at 70 days, I think HRT is very high, 70 days. We have to put it in the reactor. So it's good amount of gas produced, 5,551 ml gas we generated. So the maximum biogas of 140 milliliter gas production was obtained on 36 days. And cumulative was 5,000, more than 5,000. So here you will see that 0.5 I by S ratio, the maximum VS reduction was found. Okay, but degradation was poor, only 10.8% only. But still, I think we will able to generate good amount of gas. Is the COD, soluble chemical oxygen demand. Also, you see by 30 days. 30 days also, volatile fatty acid generation was very good. So overall digestibility was quite poor with lengthy hydrolysis phase, which demanded pre-treatment. Okay. So different type of pre-treatment we propose. The first is thermal pretreatment. So thermal pretreatment, we tried heat, dry heat, pressurized moist heat, and open moist heat, and microwave irradiation process by like various temperature with time duration, and estimate the improvement in solubilization, basically in terms of COD and VFA. So is a dry heat in hot air oven first. This is the other way, and is the different way. We added the heat. Where solubilization we found the COD and VFA production, and where we found that 140 degrees centigrade for 60 minutes was the best out of these four methods. Then this you can see the pre-treatment easily. You can see untreated one, the methane, daily methane generation, and this is the pre-treated one, red color, for I/S ratio 0.5. This is the cumulative methane production. So initially hydrolysis phase was longer. So initially in the without pretreatment, but you see here from here itself after 10 days, here itself the gas production has been increased because of pretreatment process. So upon BMP batch assay at 20 liter scale, the biogas has enhanced by 40% with 57% different degradation. This is the one research paper of the similar data. This methane production and toxicity evaluation of petroleum refinery biosludge through optimization of different mode of heat. Then we thought of another pretreatment process like electrokinetic pretreatment process, where we are trying to put two anode and cathode, so that we'll put some power or electricity will provide, and because of that degradation could be possible. So that is specially for the hydrocarbon breaking we are targeting. So there are three principles we are working, like electromigration, electrophoresis, electroosmosis while in the degradation process. So this is the refinery sludge. So this is the setup of electrokinetic pretreatment condition. So we found 60 volt, 83.5 minute with the spacing between two conductor, that is 11.6 centimeter. The toxicity also you can see that whatever the sludge finally remain, we tried phytotoxicity. So you can see is the growth. So hydrocarbon removal also we checked, and cumulative biogas production also. See, pretreated one. That is 69.2% biogas enhancement. Remove all kind of phenol and organic matter. This is another research paper, like optimization of electrokinetic pretreatment of enhanced methane production and toxicity reduction from petroleum refinery sludge. Then we targeted, why not we can go for microbial pretreatment, because what we found in the all different the process, still it were required 60 days for degradation process because of non-availability of more amount of bacterial consortia. Then we thought of like Pseudomonas putida, which purchased from the MTCC Chandigarh. Then we harvested that bacterial solution, and with different serial dilution, we calculate optimum dose and pre-treatment duration. We are evaluated. So initially, a dose of 10 power 8 CFU per ml result in 3.4 and 2.21 fold increment in soluble COD and VFA. respectively as compared to untreated within 6 days of incubation. Then we targeted this BMP, 1 liter BMP, revealed the maximum biogas augmentation 62%, and VS degradation 66% was found compared to untreated one. This is the gas production. You'll see here. It's a very good. Let's see the gas production. This is the graph. So it's again closer to 50 days. This scaled up study of 20 liter result, 57% total phenol degradation, organic matter degradation also, and 91% of phenol removal was possible within 50 days of dilution. Now, this is another research paper you'll see here, like enhanced methane production and hydrocarbon removal from petroleum refinery sludge after Pseudomonas putida pretreatment and process scale. Some ongoing work from the group, like now we are targeting co-dilution studies to find the suitable co-substrate for biogas enhancement. Also, we are targeting different type of pretreatment to further enhance the biogas production from co-dilution, and also we are scaling up this batch study to the continuous level in anaerobic biphase baffled reactor. So this is the one reactor, the 20 liter size reactor. Currently, we're running as a continuous level. Continuous means fed batch system. Every day we are feeding the reactor, but only the problem, because we're looking to run around 1 meter cube of reactor or 10 meter cube of reactor. But the only problem, we're not able to get the sludge because we get permission to only 4 kg or 7 kg in every visit. I think I'll request some of you, those working in refineries, please allow us to collect the sludge, because I had a good long discussion with the Guwahati refinery people, those who are working on wastewater. I asked them the one particular reactor I can install in their refinery itself, but how they shared with me, like the outside technology, they can't accept that. Refinery people have their own research institute somewhere located in Uttar Pradesh, and whatever the technology they come with the final design, that they can take up from that particular research institute. But we were really looking to get the good amount of sludge, so that we can work for the at least industrial level biogas reactor. So just to share about what other successful trial we did in our solid waste lab by the WMRG people, like we treated food waste, even water hyacinth. I think all of you will surprise that water hyacinth, metka, pani metka, this become a very good substrate for the biogas production. Very difficult to degrade. Hydrilla is another weed. Even pulp and paper mill from this Nagaon paper mill, which has been closed now. But when they were running that, we used to collect the good amount of pulp and paper mill from that industry. Even the crop residue, rice also, even the terrestrial weed is very difficult. This Parthenium histoporosus is a Congress grass, named as in Congress grass very popularly. It's very hazardous in nature, but that also we treated very well at different our WMRG group. Also different inoculum also. Even the here piggery waste is very important to manage. That piggery of waste also we co-digested with the different waste materials. The one reactor we had a design we named as an ABBR, anaerobic biphase baffle reactor. Their HRT is only 10 days. So initially laboratory scale ABBR we targeted. and at HRT of 10 days, successfully we treated the different waste. This is the zero point 0.7 meter cube reactor is currently available with us. This is the 10 meter cube in our solid waste lab. You can see here, this is our solid waste lab, where currently we are running this 0.7 meter cube and the 10 meter cube of reactor. So this 0.7 itself can take up to 25 kg. This is one meter cube reactor for piggery waste we installed in Isol, under the that Swachh Bharat mission scheme, a Govardhan scheme. But we are looking more facility we can put up in different locations.
It's
So
again,
this
doctor.
API, yes, please.
It's in the meeting.
Okay, so we have two operations. Two are operation 1 meter cube, 10 meter cube. This is the gas production, gas storage. The biogas stored either for cooking gas or power production also we do in laboratory. If if people will visit that currently our entire lab, solid waste laboratory is running on biogas facility. Uh, we are generating around 10 kilowatt energy per day, power production. So there are different type of digester we designed, like this ABBR was the last one, like AFR, BP, CR, XPR, different reactors. And also along with the biogas process, we also generate very good amount of compost. We do is different waste materials like different aquatic weed like watericin, Fumdi biomass in Manipur, Hydrilla desilita, different weed, Azaretha, Micania, Parthenia. These all successfully we treated is the sewage sludge, peppermint sludge. So this is our pilot scale rotary drum facility, 5 meter cube facility is currently we're running, where we can feed around 400 kg of vegetable waste or any kind of organic matter we can add here. So only 7 days of composting process, where 2.5% nitrogen we're getting. So this is another vermicomposting facility is running in our laboratory. Also, we started one startup that is Upshist Management and Environmental Research Private Limited, where this Amer is planning for any kind of consultancy work, also production of vermicompost and reactors. So our production of our company is compost, rotary drum composter, biogas reactor, and vermi bag, mobile vermicomposting unit. We do the service, different services. Our commercialized product is already few location is installed. This is rotary drum composter of 5 meter cube. This is the 10 meter cube of biogas reactor. We're hoping that few more these kind of reactor will come in different part of Northeast and other areas. Already our one product, Matidhan, you people can search on Amazon. Amazon is available. Matidhan organic vermicompost is one of the best product is available online. Even you people can ask me directly. We'll transport you to your own location. So thank you. And this is our group.
Thank you, sir, for such an informative session. It was really a learning session for all of us. I'm very grateful to you for covering so many aspects of treating sludge, refinery sludge, how to treat it, and different sludges like oil sludge, bio sludge, chemical sludge. These are natural, and you are also involved in the management of this sludge from Guwahati refinery. That is really a good information for all of us to work on that area also from our side to involve
Yeah.
in that. And you have so nicely presented about different treatment and disposal methods of petroleum refinery sludges. And keeping in view the future of this conventional fossil energy, uh, as we have projected based on some literature reviews that oil by 2052, gas and coal, uh, we have certain limitations on that, and how we can uh, convert ourselves. This refinery sludge can be converted to biogas generation, or fossil fuel consumption can be
Yes.
seen converted to biogas generation. This is really a very learning session for all of us, and you have so nicely presented about anaerobic digestion processes, different stages involved in it: hydration, acidization, acetogenesis, methanogenesis, and how decaying of organic matter can be made to a flammable component, which is getting actually worldwide attention nowadays. Biogas production, as you rightly mentioned, the plant was first commissioned in India itself, and not many aspects of these refinery sludges from different industry, including paper mill and also from EMP industries. So those these treatment processes have very nicely presented, and we have been highly benefited from these discussions. And if participants have any query, they can ask directly regarding on
Some put
the.
up in the message, I think, some questions. Yeah. Can I go on this? I think
Yes,
some
sir,
send
yes,
the
sir.
message.
Yes, sir.
Like
So,
they're asking what is the average cost of your model?
yes, sir.
Yeah, cost wise, if you ask me, like 10 meter cube of reactor, we are selling for 25 lakhs rupees, uh, and with along with the all power production units along with that. And he's also asking like vegetable digestion chamber available currently in the market. Yes, I think you go on India Mart. Our company also listed in India Mart, and India Mart. You can ask me, or otherwise you send a email to me. I will provide you all the detail. Is available, and anywhere in India we are currently supplying these composter and biogas units. If anyone have any other query or any question, please have discussion with me.
Participant can unmute themselves to ask their query. One more questions in the chat box. Okay, sir, with pleasure. Thank you. Would love to get your mail if you don't mind. So,
Yeah, yeah. It's already my. I think you can search me very easily. Put Kalamdar. Or is available with the Dhruva, Mr. Dr. Dhruva
yes,
also
sir.
available.
Okay, sir, I'll share with them.
Share, yeah.
So, if there are no more questions from participants, I must mention my deep sense of appreciation and sincere thanks
Thank you.
to
Thank you. Yeah.
Professor Kalam sir for giving an excellent coverage on the topic, potential of biogas production from petroleum and refinery sludges. It was very informative and enlightening presentation, and thank you for your presence in our FDP.
Thank you. Thank you very much. Yeah. Thank you.
Welcome, sir.
Okay, so I can leave now. Yeah.
Yes,
Thank
sir.
you.
Yes.
Thank you.
Welcome, sir. Welcome. So, dear participants, we have come to the end of this session today. So, tomorrow our session will start at 10 a.m. And those who have yet to respond on attendance link, so they can be in the session till your attendance are given. Technical team is requested to provide the link. Participant, please mute yourself.